Welcome to EDU World Space.
Here we're going to look at the degeneracy in each level in the hydrogen atom. And what we mean by degeneracy is states with identical energies. So recall that N is the principal quantum number that delineates the energy state. And we are going to use an induction approach to prove that degeneracy is 2n squared. So we'll start and show that this is true for the first three levels, and then we will carry it forward to any n. There are four principal quantum numbers in the hydrogen atom. The first one is the primary principal energy level number called n, and it goes with the energy. The second one is L, which goes with the angular momentum of an individual state. The next number is M sub L, which is sometimes called the magnetic quantum number or the Z component of the angular momentum. It can only take on discrete values. And the last one is the spin of the electron. And we'll start with n equals 1. That's the easiest one, but all of these are going to have a degeneracy of 2 because the electron can have a spin plus or minus 1/2. The L, angular momentum, starts with 0 and goes to 1 less than the N. So there's only one possible L for n equals 1. And then M sub L goes from minus L to positive L in integer steps, and that can only be 0. So for n equals 1, let's make a little list of the degeneracy, is 2. And so far, so good. Our formula is working. Let's do 2n squared is 2. So yeah, that formula looks good for the first energy level. For n equals 2, we have L equals 0 and 1. With 0, it's the same thing as what we had for the L equals n equals 1 state. And the next state goes from plus 1 all the way down to minus 1. So there are 3 states, each of which has 2 spin states. So that's 6. And our degeneracy total is 8. 2n squared is 8. So that's looking good. And we'll keep on going. With n equals 3, L can be 0, 1, and 2. And we'll keep everything we had before, but add one more L state. Whoops, that should be minus 1. And the L equals 2 goes all the way from plus 2 to minus 2 in steps of 1 integer. Okay, let's see if we can get that in there right. Minus 1. And of course, the 2 spin states. So we have 2, 6, and then finally 10 for a total of 18. And 2n squared is 2 times 9, or 18. So it looks like it's holding true for the first 3 n values. And you can see what we're kind of doing. We are multiplying. The degeneracy is equal to 2 for the spin states times a sum over the degeneracy of the angular momentum states, which basically go as 2L plus 1. from L is equal to 0 all the way up to n minus 1. Okay, so notice that if L is 0, there's only one state. If L is 1, there are 3 states, etc. So double-sided for the plus and minus, and then include 0 gives us 2L plus 1. So we are going to prove our degeneracy formula by using induction. Okay, and usually you start off with an inductive proof by showing the formula works for the beginning cases. And then you're going to assume that the degeneracy goes as n squared for a general n. So we're going to assume the formula is true. I mean, it's sort of looking like it does. And if you can then show that it works for the next level up, then, and we'll put a question mark by that because we want to show it, not just state that it's true. But we want to say n prime is equal to n plus 1. And typically what you do is you write down the formula for n prime with the summation, and then you break up that sum into the previous quantity. Oops, that should be n. Okay, n prime is equal to n is equal to n prime minus 1. And then you break this up into one term plus the previous. Let's see how to say this. The sum that works for n minus 1, and then the new term. Okay, and the next term has n in it. It's just one term. So there's a sum plus a little left over. Okay, and we assumed that the sum for n was true. So we have assumed that this first sum is n squared. And so the degeneracy for n prime is twice n squared plus 2n plus 1. And now let's take a look. That can actually be turned into a binomial, n plus 1 squared. And the stuff in the parentheses is just just n prime squared. So what we have basically shown through induction is that if the sum of L equals 0 to n minus 1 to L plus 1 is equal to n squared, it is true for all n. And that's called proof by induction, where you just take one little step and show that the next step up works from the lower rung. Kind of like testing your ladder. That would be kind of dangerous, assuming that all steps are good from one step and the next step up.